that would not have been the case. And for me personally, I probably wouldn't be doing any PHP right now if I hadn't found Composer when I did. So I blame Composer for the reason I'm still doing PHP, because it's an amazing tool that made it a lot easier to share code, which is all about dependencies. And I like that because I'm able to use other people's code more easily, and I was able to write more code easily that other people could use. And if you know anything about me and some of my little projects, I like to write little tiny pieces of code that people can share. So Composer made that easier for me to use stuff, distribute things. It's an amazing tool. But dependencies also have some downsides. And these are things that I don't think people talk about often enough. And it's things like security. If you bring other people's code into your code base, any security issues in those libraries or those dependencies are now your security issues. It can also be difficult to keep track of the things that are changing. How many people are required by their project to look at all of the code that they bring into the project? Like any dependencies? Is anyone here in that situation? Okay, I know some projects that before you can use a library, you need to audit every line of every piece of code that you bring into your project. Composer makes it really easy to bring code in, but it doesn't necessarily make it easier to audit those changes. So if you bring in something new, someone might have done a minor little patch release and broken everything, or introduced some sort of vulnerability that you weren't expecting. Once you start dealing with dependencies, you also have to worry about version conflict. This can both be like version lock, where you can't install two things at the same time because they require different versions of the same dependency. And it may be the case where a version says that it works with your version of another dependency that doesn't actually work as advertised. Semantic versioning tries to help this, but that doesn't always make it easier, especially if someone increments a major release. Like if you're looking at, say, Guzzle. How many people have run into Guzzle issues trying to, so Guzzle is very prolific in the community right now, and there's a lot of people who are using different versions of Guzzle, which means that if you have two versions, two different packages using the same different versions of Guzzle, you're not going to be able to install all of your dependencies very easily. Some projects also have slow release cycles or don't have an advertised release cycle. Symfony is pretty awesome now because it has a predictable release schedule, which is pretty nice, but not everyone does that. Projects also become abandoned if you're relying on a library that is no longer being maintained, either intentionally or just because the maintainer or maintainers have gotten busy. That can make your life a little difficult, especially if there's bug fixes that need to be pushed out into new releases, features that you've been waiting for that have been on Dev Master for a year and a half and just are not in an actual public release. Sometimes projects end up having different goals than you do. This can be the case where right now I have a friend who is trying to work with RethinkDB. And the PHP driver for RethinkDB is very different than what he was hoping to see in a RethinkDB driver, like vastly different. And right now he's struggling with the question of, should I try to mold my project to this other way of doing things? Or should I write my own driver? Or should I try to find a way to get this other library author to sort of change a little bit of things to make it a little easier for me to use? So these are the kind of problems that you might run into when you look at bringing a dependency in. Now you have to rely on other people's interpretation of things. So if you have a dependency and you need to start making changes or doing any sort of work on it, then you need to start to figure out how to work on the dependencies. And Composer doesn't do a very good job of this. It has some tools that we'll look at, but it isn't always very painless. The first thing that people want to do sometimes is do debugging or doing some sort of bug squashing. Like if you're using a dependency and you want to figure out why something's happening, so maybe it's a problem in your code, but you need to do some trace statements or set some breakpoints in a dependency, then you need to figure out how to do those sorts of things. And the easiest way to do that is doing development in the vendor directory. How many people do this as their first line of defense when you start working on dependencies? A couple of people? Okay. I know that I think the Drupal community does this quite a bit because they were one of the big proponents for PSR4 to make the vendor directory not so deep. So I know that this is a thing that a lot of people end up doing. It's very handy because you can just start doing it. You just jump right into the vendor directory, the code's there. You can just make changes as you need to. It's pretty nice. The downside is that you may end up having to make a change in Composer JSON, even though everything works while you're doing the debugging. So again, live debugging works really great. Unless you're using one of the class map autoloaders or something like that, you're going to be able to find all of the files. Everything is already there. If you plan to actually start making changes, or if you end up having to make a change to fix a bug, you better have had dev installed or done proof of source the last time you ran Composer update or Composer install. And the reason is that Composer by default will try to install a tag version which doesn't have a live VCS directory, which in most cases that's going to be a Git repository. So if you don't have that, then you're going to have a lot of fun when you decide to try and take your changes that you've made and publish them somehow. If you do end up getting a VCS checkout in your vendor directory, you'll notice that there's a Composer remote. And this is the remote that Composer adds so that Composer can manage the Git versions that get checked out. So what you're going to want to do in this case is add your own remote. So if you already have a fork, you can use that. If you need to create a fork, you can create that. But ultimately, you need to add your own remote to the vendor directory checkout, and everything should be fine. You can persist the changes, you can commit them, and then you can push them up, and you have a PR now that you can submit to your upstream dependency. Oftentimes, what I end up doing is I will create a longer-term relationship with one of my dependencies. I'll actually fork it, bring it into its own directory so I can do development on it, sort of independent of the application that I'm using. How many people end up doing this? Okay, not as many people end up doing this. But this is more of a long-term thing that you want to do. It does let you start working on it within the workflow of the dependency itself, which can be nice. You'll run Composer install, run all the tests. But it does still end up requiring you to change your application's Composer JSON to be able to look at this new clone that you've created. If you do create your own fork, you need to start looking at the difference between overwriting the package and renaming and replacing it. Overwriting is probably what you should be doing. And what that means is that the Composer JSON for your fork keeps their vendor and their package name, so nothing changes at all. So this would be overwriting the package. This means that the consumer of your package or the consumer of your fork can still require the original package name and have it work. The alternative is to rename the package and then use replace. And it's important to know that you don't have to rename your package just to work on it. I think this is a pretty common thing that I see people do, is they will fork a project, they will rename the dependency within their Composer JSON to be their GitHub username / package name. That is not exactly how Composer works. Composer doesn't care what the VCS URL is, it just looks at the name of the package. So keep in mind, if you do decide you need to create a fork of a project and work on it, you don't have to change the name just because you want to do some work. What happens is, if you use in your fork my vendor / their package, when the consumer tries to require this, what they're going to end up seeing is nothing. They're not going to see your changes at all, because the consumer is still going to be looking for their vendor, their package. So it isn't going to have any way at all to find the new package that you've just named. So this is one of those common misconceptions that people have, that it ends up making a bigger problem for them because they don't know what's going on. I tried my fork, it's not finding it. It's not finding it because Composer doesn't know anything about the new package name. Composer does provide an ability to do this, though, by using the replace key. And the replace key lets you say that this package with a completely different name replaces another package for a specific version. But this isn't necessarily something that you're going to want to do for a short-term project. This is for a bigger, these are for bigger cases where you're actually wanting your dependency to be replacing another dependency for some reason. Symfony itself uses this for the components. The Symfony / Symfony project replaces all of the subcomponents for the version that Symfony exists for. So replace is something that people see often, more often probably than some of the other tools, but it's not really well understood. So if you're a Symfony developer, you look at Symfony, hey, replace key, I should use that. No, Symfony's using that for a very specific reason, and it's probably not what you're looking for if you just want to do some work on a package. Just naming your package the same isn't actually going to do a lot of good. You also have to be aware of Composer repositories. And the way that you would configure those is with the Composer command line. Repositories.somename, and that name is arbitrary. You can use the package name if you want to. You need to give it a type, and then you need to give it the URL for that repository. And the first repository we'll look at is the VCS repository. And this is, if any of you who've created standalone packages, you'll be familiar with the VCS repository. So in this case, if I've now created a fork of their vendor, their package, at me/their package on GitHub, I would have to add a repository that points Composer to a VCS repository specifically to that GitHub URL. And what this does is instructs Composer to look at that Git URL to determine what package lives there, and then any package that lives there overrides or has higher precedence than the packages that are available on Packagist. For Git, you can also use a file URL. So this can be kind of nice because you can commit changes to your repository, check them out to make sure that they work within your actual application without having to push the code to GitHub. If you use a Git URL like this, which is a GitHub URL, you'd actually have to push the changes in order for Composer to find them. If you use a file URL, you simply have to commit them. But even that can be a little painful sometimes. You don't always want to commit changes. You want to do debugging, live debugging, and there's another tool that we can use that lets you do that without having to commit first. But first we're going to talk about as. How many people have used the as? Smaller number of people. Okay, awesome. So Composer's as lets you rename a version to another version. So if you have, say, created a bug fix in a branch called myfix, you can tell Composer in the consumer's Composer JSON to use dev myfix, which means use whatever is the current version on the myfix branch as 1.0.5. This means that any dependencies that require that dependency now, so if they require caret 1.0, this will now match that. So this is a people that I pushed my code up, Composer, I added the remote, it doesn't seem to be working. This is why. You need to actually tell Composer which branch to use and which version to pretend to be. These are fine solutions for short-term maintenance, like you may want to do like a bug fix or debugging sort of things. But if you want to do some more long-term work, if you want to create a longer-term relationship with a dependency, maybe you have a maintenance thing within your company where you need to say, okay, I'm going to support this particular version of this dependency, and I'm going to make commits to it, but we aren't going to take any more commits upstream. You might want to do this if you have an abandoned project where now, hey, we are going to keep our own fork of this project, and maybe we're even going to publish it. That'll be fine, or maybe we're going to keep it private, but the project's abandoned. There's no way that you're going to get any more changes, so you need to take ownership of it yourself. You might also run into cases where pull requests are refused or simply ignored. Ignored pull requests might be a sign of an abandoned project, in which case you might want to consider owning the project yourself anyway. But sometimes pull requests are refused. This would be the case when you're trying to change an API that is backwards compatible or against what the original author wanted to do with the package. You don't really have much choice. You can't force them to accept your pull request. So at that point, you need to determine how are you going to fix that. And chances are you're going to need to create your own fork that you're going to maintain long term. This also gives you more ownership over a project. If you do a long-term fork of something, you control everything that goes in, everything that goes out. So it can be nice to do that, even if you're using a public project and you are going to actually keep up to date with the master of that project. But you can still own it. You can still bring in the pull requests one at a time if you need to. It gives you a lot more control if you have your own fork. It also lets you track the changes a little easier because you can actually see the changes as they come in. You know everything within the code. You don't have to take a change log. You don't have to take their word for it. You can actually see it come in that way. If you have long-term forks, or if you're in a shop that has a bunch of private repositories, it probably makes sense to create global repositories. And the command for doing that is composer config -- global. And this will enable the repositories across the board. So anyone who runs Composer within this environment now will automatically go hit the repositories that are configured globally. And this means that individual Composer JSONs for applications don't have to have a string of private repositories added anymore. We already talked about VCS repositories. The problem with VCS repositories is that they're slow. Composer does what it can to try and cache these, but anytime the cache fails, it has to rescan the whole repository every time to see which versions of that project are available. So it can add up after a little while, especially if you have multiple VCS repositories. Every time the cache breaks, it might add another minute or so to Composer, depending on your connection, depending on how big the repositories themselves are. So it can be a problem. The solution to this is to use Composer repositories. And this isn't like a Composer repository, it's like a Composer repository. It's kind of a confusing name. What this does is it basically has the pre-scanned version of all of the projects and the dependencies available as a string, rather than having to go through Git and determine this information on the fly. So this is a lot faster on the edges. So anywhere the Composer command itself is run, no longer has to scan the VCS directories. It just asks the upstream Composer repository what packages are available and which versions, and then it can go from there. So it no longer has to do the work itself. The upstream repository has already done that. And everyone's already using a Composer repository, even if they aren't really aware of it. Packagist itself is a Composer repository. It's a very, very large Composer repository, but it has all of the information for all of the dependencies in its database. So it can just give you, it can give your Composer the information it needs without your Composer having to go to each individual dependency to find out which versions are available. This is probably overkill for most people to install Packagist, which is an open source application. So you probably don't need users and all of those sorts of things. I've seen more people using something like Satis. Satis is a command line application that generates a static Composer repository. Because it's static, it doesn't have a web interface or anything like that. You can configure it to rebuild on a cron job, or you can configure it to rebuild on a push. So that means that every time you make a change to your code base, Satis will run, re-update all of its Composer dependencies, and publish those so that the other people on your team can use them. Another tool that is sort of in between Packagist and Satis is Toran. Toran Proxy is a little more dynamic in that it's more of an application than Satis is. It is a proxy, which means you can set it in front of all of your developers, and it will cache requests to Packagist. So you can actually get all of the Packagist requests that are made within your development team pushed through Toran, and the actual dependencies that are installed downloaded locally to Toran. Which means you can also disable Packagist, which is something that people don't often do. But you can disable Packagist on individual Composers so that it only will get the information that you're actually wanting to get from the repositories that you want to get it from. I've seen a lot of people talking about monolith repositories lately. It seems to be a big thing right now. Facebook's doing it, and they had a big blog post that sort of set off a bunch of people discussing this, at least in my little world. This is sort of putting all your eggs in one basket. So one repository that has all of your applications and all of your local components. So rather than having individual components or individual repositories, each with their own Composer JSON, you have all of that in one directory. And a tool that Composer gives us to help us with this is a tool similar to Replace called Provide. And what Provide does is it lets you say that this Composer JSON and the application around it and all of the autoloader configurations provides another package. So this would be a way to say that within my application, I've downloaded somewhere their vendor, their package at version 1.0.3. I've configured this Composer JSON's autoloader to look in the right place to find all of those files and advertise the fact to your dependencies that I have fulfilled their vendor, their package 1.0.3. So this is a way to make sure that any of your dependencies that look for that package are able to find it in your location. So it's a nice way to let you add additional packages to a single application. If you look at the replace command, it's better for distributed components, each with their own individual Composer JSON files. If you have an application that says, I replace their vendor, their package, what this is actually telling Composer is, if you are looking for their vendor, their package, you can install my package, or my application instead, which is not really what you're looking for. So there's this subtle difference between replace and provide in the way that they're intended to be used, but they behave very similar in what they actually do. So in this case, it's probably more reasonable to say that my application provides this dependency as opposed to you can install me instead of that dependency. They accomplish the same thing, but it's a subtle difference in how it works. So again, if you want to use replace, you would want to do that in a fork. So the fork actually replaces another version of itself, as opposed to the whole application. Path repository can be super useful if you have a monolith, because you can just do relative pathing to where the other modules, composer.json files, live. It doesn't solve all of the problems that you might have in this particular case, but it does get you a little closer. There are some tools out there that I've seen people putting together to try and solve these sorts of problems, specifically the monolith problems. One of them is called Fiddler, and Fiddler uses Composer JSON in the root, and then the components have a fiddler.json file that redirects Composer to look at different places. It's a lot more complex build process than just running Composer install, but it's one of the two methods that I found that you could try to look at if you're running into this kind of problem or considering trying to use Composer in an environment where you have multiple components or multiple applications in one repository. Another implementation I've seen is called Conductor by MyBuilder, and it uses a similar idea to what Fiddler does, but it does it with artifacts and symlinks. So it has another build process that it uses. So either of these could be interesting to look at if you're looking looking for a solution for running multiple Composer projects within one repository. There really is no good solution I've seen for version conflicts. For example, the most recent instance I've had of this personally was with Symfony console. I had a project that was using Finks for database migrations, and it was tied to Symfony 2.7 console component. But I also wanted to write my own console component that was requiring Symfony 3, because I wanted to experiment with some of the Symfony 3 things. So my only solution at that point was to say that my component needs to support 2.7 or 3.0 at dev. There's really no way around this. We already talked about Guzzle. Guzzle is probably the biggest offender that I've seen on this. It's not Guzzle's fault necessarily, other than rapid major release cycle, but it is something that is probably the biggest impact I've seen on this community. Just dealing with ramifications of Guzzle conflicts. A more personal example that I have is with Stack. How many people are familiar with Stack? A handful of people, okay. Stack, behind the scenes, most of the Stack middleware actually use Pimple1 as a container. So we try to hide the fact that Pimple is even in the mix. But you pass in the configuration, and internally the middleware will have a little container that is configured based on what you pass into the configuration, and it does some stuff, which is really great. The problem is that every single Stack middleware that I'm aware of that uses Pimple is still completely incompatible with Silex 2, because Silex 2 uses Pimple 3. And there's no way to resolve this really, short of actually going in and updating every single Stack middleware to have a new version that has Pimple 3 instead of Pimple 1, which really doesn't seem like it should be a problem at all. Which makes me ask the question, why did my Stack middleware have to depend on Pimple anyway? The answer, of course, is reuse. We talked so much now about reusing components. It's so easy to do that people are almost laughed at if they don't reuse components. But I don't know if that's always the best solution, especially in the case of Stack, where it really could have been any component. It could have been any container. Just so happened it was Pimple because we were, the people who wrote Stack were largely Silex developers at the time. And hey, we're using Pimple for Silex. We'll use Pimple behind the scenes. Great, we'll only install one container. Didn't quite work out that well, and it's probably not the best way to do it. A friend of mine, Dave Marshall, doesn't really have a motto necessarily, but he advocates just copying it. Sometimes, if reuse isn't easy, don't try to reuse it. It's sometimes not worth it, especially if it causes a lot of problems. If you do copy code instead of installing with Composer and actually using dependencies, you have a lot of advantages, mostly in that you own everything. It also comes with a lot of disadvantages, and that is that you own everything. You now have to manage everything, and it can be a little more difficult to keep track of security and whatnot, but it may be better than some of the alternatives. So we've actually talked about creating a project called Decomposer that would make this a little bit easier, which is sort of the inspiration for the title of this talk. To make this sort of process easier, because we both have done this a lot, we'll take packages, we will copy little bits of them into our own namespace so that we don't have to worry about version conflicts or anything like that. But that's an extremely manual process. And with a lot of the tooling that we have available today, it should be relatively easy to automate that kind of process. So it's kind of a joke project, but we actually do have a repository, so we may actually create that someday. But what all of this comes down to is, if you're working with dependencies, you need to keep in mind that you are taking someone else's code into your project. And you need to be aware of all the ramifications of that, and understand how you can work with them, understand whether or not you trust them. So keep in mind the next time you want to do a Composer install or a Composer require of a new dependency, think about all of the dependencies they are bringing in. Think about all of this code that you didn't have to write, which is great, but you still have to deal with the ramifications of that code failing, that code having security issues. Make sure that, if you're going to bring in a package for one class that you're going to use, you're bringing in, 300 other files that you don't know exactly what they're doing, unless you actually go through and read all of the lines of code. So be sure that when you're actually trying to require dependencies that you know what you're doing, and think about it a little more beyond just Composer require. That's all I have for right now. I have time for questions. Lots of questions, I hope. Anyone questions? No questions. All right. Yes, one question.
Can you elaborate on the difference between replace and provide again?
Yes, the difference between replace and provide. The difference between replace and provide, replace says that your package can be replaced by this component, or by this package that you're working on. Provide means that this package provides the functionality that is there. The Composer docs don't really go into it in a whole lot of detail, and it really depends on how you look at it. So if you fork doctrine, say, and then you call it something completely different, you can say that my package replaces doctrine. So if you install, if someone wants to install doctrine, your package can be listed as a possibility to install instead. The way that the docs talk about provide deals with interfaces. So PSR, the PSR3 logging interface is an interface package. So the interface package is, I think it's PSR log implementation. So monolog provides the implementation because monolog provides the PSR logging implementation. So provide was meant more to say that my application provides this functionality, but not necessarily that you can install it instead of something else. If you have a framework, for example, your framework might provide PSR logging. So you can provide logging that way. So you're not saying that my whole application can be installed instead of PSR logging. You're saying my framework will also provide logging built into it. Does that answer the question a little better?
Yeah, I guess so.
Yes, okay. It is very subtle. They do exactly the same thing as far as I know. It's just intention. You're advertising the intent of what you're doing. Another question?
Yes, will Composer complain about two packages be providing the same implementation?
The question is, will Composer complain if two packages claim to provide the same implementation? I don't believe it does. I think that Composer, if you require PSR logging, PSR logging itself requires PSR logging implementation. So by requiring PSR logging, you're required to also require an implementation. So if you install monologue, that dependency is satisfied. At least one thing has provided PSR logging implementation. If you install monologue alongside something like, say, Laravel, where Laravel also says it provides logging, a different logging mechanism, Composer doesn't care. All it knows is that it needed logging has been satisfied. Yeah. Yep, you're welcome. Any other questions? Okay, I guess that is it then. If you have questions, you can come up here. Otherwise, thank you very much.